Welcome to Astronomy Daily, your go-to podcast for all the latest and most intriguing news from the cosmos. I'm your host, Anna. Get ready to explore the mysteries of Mars as new data from the Curiosity rover sheds light on whether the red planet was ever truly destined for life. We'll also peer into the lives of cosmic giants, those incredibly massive stars that vomit vast amounts of matter before collapsing into black holes, a process far more dramatic than we previously imagined. And speaking of drama, we'll uncover how decades-old Hubble images helped astronomers track down an elusive rogue planet wandering through space. Finally, prepare to be amused and amazed as we count down some of the strangest man-made objects floating around in Earth's orbit, from glittering pea crystals to a Tesla Roadster with a dummy driver. So buckle up, and let's journey through the wonders of astronomy and space. Now let's turn our attention to our dusty red neighbor, Mars. For years, scientists have pondered whether the red planet could have once harbored life, with evidence like ancient lake beds and rivers hinting at a much warmer, wetter past. But a fascinating new study, drawing on data from NASA's incredibly resilient Curiosity rover, suggests a more somber truth. Mars might have always been destined to be the cold, lifeless desert we see today. It's a huge, unanswered question, as Edwin Kite, an associate professor at the University of Chicago, and the lead author of this study puts it. Why has Earth managed to keep its habitability while Mars lost it? His team's models propose that those periods of warmth and wetness on Mars were actually the exception rather than the rule. Essentially, Mars seems to self-regulate itself as a desert planet. We're truly in a golden age of Mars science right now, with multiple rovers on the surface and a fleet of orbiters giving us unprecedented insights into its history. So what's the secret to maintaining a habitable world over billions of years? It's not enough for a planet to just start off warm and wet. You need robust mechanisms to stabilize those conditions responding to environmental changes. On Earth, we have this incredible system of carbon cycling. Carbon dioxide, or CO2, in our atmosphere leads to a rise in temperature. But this warming effect then speeds up chemical reactions that lock that CO2 away into rocks, preventing runaway global warming. Then, through volcanic eruptions, that carbon slowly leaks back into the atmosphere, restarting the cycle and maintaining a stable climate. Mars, however, lacks this crucial balancing act. Unlike Earth, where volcanoes are almost always erupting somewhere, Mars is currently volcanically dormant. The rate at which volcanic gases, including CO2, escape into the Martian atmosphere is incredibly slow. This means that any CO2 that got locked up in Martian rocks during those brief wet periods didn't get recycled back into the atmosphere. If there was even a little liquid water, it would continually draw down atmospheric carbon dioxide through the formation of carbonates, like the siderate material that Curiosity actually found. Without volcanoes to replenish it, the atmosphere would thin, temperatures would plummet, and the planet would dry out. Kite's team used sophisticated computer models, directly informed by data from the Curiosity rover, including that crucial discovery of siderate. Their simulations paint a picture of Mars having short, fleeting, warm, wet periods, but these were consistently followed by vast stretches. We're talking 100 million years of intensely dry desert conditions. Not exactly ideal for life to truly take hold and flourish, is it? It seems Mars was indeed, in a way, doomed from the start. From the mysteries of Mars, let's rocket off to the other end of the cosmic scale and talk about some truly colossal objects, very massive stars. These aren't your average stellar bodies. They're like the rock stars of the universe, powerful, living fast, and dying young. And surprising new research reveals that these cosmic giants, before they collapse into black holes, might vomit out much more material than we ever thought, through incredibly powerful stellar winds. Imagine winds so strong that they're less like a gentle breeze and more like a cosmic hurricane, blowing the outer layers of these monstrous stars into space. While our sun is expected to live for about 10 billion years, these very massive stars burn through their nuclear fuel at an astonishing rate, sometimes living for only a few million or even a few 100,000 years. Their lives may be short, but their impact on their environments is profound. These strong winds, along with their eventual supernova explosions, eject newly formed elements into the vastness of space. Many of these elements go on to form the building blocks of new stars, and crucially, others like carbon and oxygen are the fundamental ingredients for life itself. Plus, these stellar behemoths are the progenitors of black holes, including the binary black holes that eventually merge and send out those ripples in spacetime we call gravitational waves, which we can detect here on Earth. For a long time, the behavior of these incredibly rare, massive stars has puzzled astronomers. Observational constraints were few and far between. But thanks to recent direct observations from space and ground-based telescopes, especially in the Tarantula Nebula of the Large Magellanic Cloud, scientists have finally been able to study stars with masses over 100 times that of our Sun. These studies revealed that the most massive stars in the Tarantula Nebula are a specific type of hot, bright Wolf-Rayet star at the end of their hydrogen-burning phase. What was odd was that these stars were found to be extremely hot, sometimes up to 50,000 degrees Celsius, which contrasted with standard models that predicted they should expand and cool down as they age. So, how do you make the observations and the theory match up? The research team, led by Kendall Shepard from the Institute for Advanced Study in Italy, worked a new mass loss recipe into their stellar evolution code. Their new models, featuring these much stronger stellar winds, could finally match the observations. The powerful winds strip away so much of the star's outer layers, preventing it from cooling down, while maintaining the surface composition that matches what was observed. The star stays more compact and hot for longer, exactly reproducing what telescopes have shown us. This new understanding even sheds light on the origins of the most massive star ever seen, R136A1, which is found in the same Tarantula Nebula and boasts up to 230 times the mass of our Sun. The model suggests it could have been born as a single, truly ginormous star, or perhaps formed from a dramatic stellar merger. This could even hint at a revision to what we thought was the upper limit for how massive a star can be in our local universe. But the implications don't stop there. These stronger stellar winds and the rapid mass loss they cause also have a significant impact on the masses of black holes formed when these stars finally collapse. Because the stronger winds strip away so much of the star's mass during its lifetime, these stars end up forming smaller black holes at the end of their lives. This helps reconcile models with what's actually observed in nature, as it means fewer of those elusive intermediate mass black holes are produced, objects that have proved notoriously difficult for astronomers to find. Even more exciting, when the team looked at binary black holes in their simulations, the new models with stronger winds were able to produce systems where both black holes were very massive. This is a crucial breakthrough because such massive binary black holes have been observed by gravitational wave detectors, but previous models with weaker winds struggled to explain their formation. The stronger winds actually push the two stars in a binary system further apart, preventing them from merging too early and allowing them to survive as a pair of black holes that can then slowly spiral in and eventually merge, sending out those detectable gravitational waves. This research, though focused on a specific environment with a unique chemical composition, opens the door to a much broader understanding. The next step for scientists will be to extend this study to a range of different initial compositions, modeling various environments across the universe. It will be fascinating to see how much the predicted black hole populations change with these differing cosmic ingredients. Now, from the immense power of collapsing stars, let's turn our attention to something much smaller, yet equally elusive, a rogue planet. Astronomers have recently achieved a significant first in exoplanet hunting, using decades-old images from the venerable Hubble Space Telescope to investigate a mysterious event that could very well reveal the existence of a rogue planet, a world drifting through space without a host star. This fascinating discovery centers on a brief astronomical phenomenon detected in May 2023 by ground-based telescopes, known by the catchy name OGLE2023BLG0524. The event lasted a mere 8 hours and was caused by gravitational microlensing. If you remember, this is an effect predicted by Einstein, where a massive object acts like a cosmic magnifying glass, briefly brightening the light from a more distant object as it passes directly in front of it. What makes this particular case extraordinary is a stroke of pure astronomical luck. Astronomers realized that the same patch of sky had actually been photographed by Hubble way back in 1997. It was purely by chance, during observations of a completely different micro-lensing event. This incredible coincidence created a 25-year baseline between the original images and the recent planetary detection, a time frame far longer than any previous study of its kind. The short duration of the 2023 event strongly suggested it was caused by a free-floating planet, also known as a rogue planet. These are worlds that have been ejected from their original solar systems, now wandering through the galaxy, unattached to any star. They can be kicked out through various gravitational interactions, perhaps with other planets, encounters in crowded star clusters, or even the violent death of their host star. Rogue planets are incredibly difficult to detect because they generally emit no light of their own. Gravitational microlensing offers one of the very few ways to find them, but distinguishing between a true rogue planet and a regular planet orbiting very far from its star requires additional evidence. This is precisely where those archival Hubble images became absolutely crucial. The research team, led by Mateusz Kapusta from the University of Warsaw, used the 1997 Hubble images to search for any companion star that might be hosting the planet. If the lensing object were actually a planet in a wide orbit around a star, that star should theoretically be visible in Hubble's high-resolution data, even from 25 years earlier. Their analysis found no evidence of a stellar companion, significantly strengthening the case that OGLE 2023 BLG0524 is indeed a rogue world. The team estimates its mass to be somewhere between that of Earth and Saturn, depending on its location in our galaxy. This study powerfully demonstrates the immense scientific value of archival telescope data. The 1997 Hubble observations, though high resolution, were relatively shallow with short exposure times. This meant the team could only rule out stellar companions brighter than a certain magnitude, leaving the possibility that dimmer red dwarf stars could still be lurking undetected in the data. However, this work also points the way toward even more powerful future studies. Next-generation telescopes like the James Webb Space Telescope, with its enhanced infrared capabilities and sensitivity, should be able to detect much fainter potential host stars and provide more definitive answers about the nature of these lensing events. Looking further ahead, the Nancy Grace Roman Space Telescope, scheduled to launch in 2027, will conduct an extensive microlensing survey and is expected to discover thousands of new rogue planets. Coordinated with archival observations from other space telescopes, these missions could finally reveal the true population of these mysterious rogue worlds wandering our galaxy. From naturally occurring rogue planets to something distinctly man-made, let's embark on a fascinating journey through some of the strangest objects our species has intentionally, or accidentally, sent into the void. When the Soviet Union launched Sputnik 1 back in 1957, it marked the beginning of humanity's presence beyond Earth. But in the decades since, we've done more than just launch satellites and scientific instruments into orbit. We've sent art, ashes, accidents, and some truly outright oddities. Let's start with something surprisingly basic: human pee crystals. Yes, astronauts pee. And for decades, urine produced aboard spacecraft was simply released into space. Once expelled, it would instantly freeze into a cloud of tiny, glittering crystals, a twinkling golden mist visible through the portholes. Some astronauts have even described the sight as beautiful. More recently, the International Space Station installed a high-tech filtration system to recycle urine into drinking water, which is a much more sustainable approach. Then there's Elon Musk's cherry-red Tesla Roadster, complete with a spacesuit-wearing dummy named Starman in the driver's seat. Launched in 2018 aboard the maiden voyage of the Falcon Heavy rocket, it overshot its intended Mars orbit and now loops around the sun every 557 days, a cosmic billboard for SpaceX. Not all space toys are left behind by accident. In 2011, NASA's Juno probe launched toward Jupiter, carrying 3 tiny Lego figurines, made from aluminum to withstand the brutal radiation of the gas giant. The minifigs represent Jupiter, his wife Juno, and Galileo Galilei, the first person to observe Jupiter's largest moons, all aimed at inspiring young people in science. And finally, hurtling through interstellar space, the twin Voyager spacecraft carry one of humanity's most ambitious attempts at cosmic communication, a pair of gold-plated phonograph records. Curated by Carl Sagan and his team, these iconic golden records include greetings in 55 languages, recordings of a baby crying, a heartbeat, the sound of waves, and music from across human history, including Bach, Beethoven, and even Chuck Berry's Johnny B. Good. They're meant for any alien civilizations that might stumble upon them billions of years from now. Speaking of iconic figures, it seems only right that Gene Roddenberry, the creator of Star Trek, should find his final resting place among the stars. While previous attempts to launch his ashes into space either failed or ended in atmospheric re-entry, a successful launch finally took place in January 2024. This time, a portion of Roddenberry's ashes made it beyond the Earth-Moon system and into deep space, where they will now drift forever. But not all space art or oddities are officially sanctioned. Back in 1969, artist Forrest Myers devised a plan to smuggle art onto the moon aboard Apollo 12. NASA wasn't interested, so Myers covertly handed off a tiny ceramic tile etched with artwork from 6 famous artists, including Andy Warhol, to an insider working on the lunar lander. This tile, dubbed the Moon Museum, was reportedly installed without NASA's knowledge. Warhol later claimed his contribution was just his initials, but the etching on the tile looks very much like a crude drawing of male genitalia. It's certainly one of the more unusual and cheeky pieces of art in the cosmos. And while some objects are sent into space with great intention, many more are just junk. We've left a lot of forgotten stuff up there, and it's starting to get dangerous. Space debris includes everything from dead satellites and spent rocket boosters to tiny flecks of paint and broken antennae. Some pieces travel at over 27,000 kilometers per hour, fast enough to cause catastrophic damage on impact. The problem has grown so severe that experts warn of the potential for Kessler syndrome, a chain reaction of collisions that could make Earth's orbit unusable for decades. Adding to the bizarre collection are relics from the Cold War. For example, in 1963, the U.S. launched 480 million tiny copper needles into space as part of Project Westford, intending to create an artificial ionosphere for bouncing radio signals. Most of these needles eventually fell back to Earth and burned up, but not all. Clumps of these tiny metallic slivers still orbit the Earth today, a strange reminder of just how far Cold War paranoia was willing to go. And then there's J002E3, a mysterious 60-foot-long object that orbits Earth, spinning once every minute. First detected in September 2002 by an amateur astronomer, it was initially mistaken for an asteroid. But further analysis revealed it was not natural, it was built by humans. Experts now believe it's likely the long-lost third stage of the Apollo 12 rocket, which launched to the moon in 1969 and was thought to have vanished into deep space. The cosmos truly is a fascinating, if sometimes messy, place. And that brings us to the end of another fascinating journey through the cosmos here on Astronomy Daily. I'm your host, Anna, and I hope you enjoyed today's episode as much as I enjoyed bringing it to you. Before you go, remember you can visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter to get all the latest space and astronomy news delivered straight to your inbox. You can also catch up on all our past episodes and dive deeper into the topics we discuss. And of course, don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts, so you never miss a moment of cosmic wonder. Until next time, keep looking up.